Hydropower is renewable energy resource because it uses the Earth's water cycle to generate electricity. Water evaporates from the Earth's surface, forms clouds, precipitates back to Earth, and flows towards the ocean. The movement of water as it flows downstream creates kinetic energy that can be converted into electricity. On a worldwide standpoint, it is the most widely used form of renewable energy. Hydropower has been used for centuries by humans. The electricity is typically created when the water is passed over large mechanical turbines. The water pressure forces the turbines to turn. The mechanical energy created is then converted into electricity. Hydropower has now become the best source of electricity on Earth. History proves that the cost of this electricity remains constant over the year. Because of the many advantages, most of the countries now have hydropower as a source of major electricity producer. The government has taken a number of initiatives in recent years to improve the functioning of the power sector and attract investment. There has also been a special emphasis on accelerated hydropower development. The following aspects are highlighted in this lesson. Future prospects of hydroelectric power in India. Advantages and disadvantages of hydroelectric power plant. Policy, future plans. The National Electricity Policy (NEP) aimed to achieve the following by 2012. Per capita electricity available of 1000 units, installed capacity over 2 lakh megawatts, inter-region transmission capacity of 37,000 megawatts, spinning reserves of 5%, minimum lifeline consumption of 1 unit per household per day. Quality and reliable power, strategies for accelerated hydropower development. To name few initiatives are policy liberalization, ranking of potential hydro sites, Prime Minister's 50,000 megawatts, hydroelectric initiatives, streamlining of clearance procedures. Institutional and budgetary support. The government has also taken a pragmatic view that in the immediate future, the public sector would have to play a dominant role in developing hydropower. A number of hydropower corporations have also been established in the central sector in the joint sector, central and state. This includes the NHPC, North Eastern Electric Power Corporation, NEEPCO, Natpa Jakari Power Corporation, NJPC, now Satluj Jal Vidyut Nigam Limited, SJVNL, and Tehri Hydro Development Corporation, THDC. Besides, the National Thermal Power Corporation, NTPC, has been authorized to take up hydro projects. Narmada Hydro Development Corporation, NHDC, a joint venture of the National Hydroelectric Power Corporation, NHPC, and the Government of Madhya Pradesh, has been constituted to implement Indra Sagar 1000 megawatts and Omkareshwar 560 megawatts projects. Status of water resources projects in India. Peninsula, hydro and water resources development in reasonably good. Himalayan region has the bulk potential to be tapped. Himalayas being geological young formations with frequent changes in the rock conditions are known for throwing up surprises. Geological surprises are one of the main cause of time and cost overrun and affects resources development. Geotechnical issues in water resources projects. Variation in lithology and rock mass clarification. Variation in projections. Tectonic stresses. Heavy and sudden gush of water. Napta Jakari and Dulhastni projects. Geothermic problems. Presence of poisonous gases. Ranghanti project. Shear zones. Massive rock falls. Napta Jakari project. Remedial measures to geotechnical issues. Geotechnical surprises occur due to number of factors and it is difficult to eliminate these factors totally. However, this could be minimized by adopting suitable means during planning stage, investigation stage, design stage. The geotechnical issues or surprises can be minimized through construction methodology, construction equipments, construction sequence, construction supervisions, quality control, instrumentation, back analysis, documentation. Advantages. Hydropower is self-contained power with all its necessary elements inbound. It does not depend upon outside sources for supply of primary energy for consumption. India is blessed with immense amount of hydroelectric potential and ranks 5th in terms of exploitable hydro potential on global scenario. Hydropower potential is assessed at 1,48,700 megawatts, out of which bulk potential is still to be harnessed. Pump storage potential is assessed at 93,920 megawatts. Hydropower, due to its versatile operating characteristics and prominent technical features as mentioned below, is favorable option. They have short run-up times with low stress on the plant. They are ideally suitable for frequent starts and stops. Low starting losses, wide, quick and easy output, variation rates, part loading can be easily implemented, better capability to handle voltage fluctuation, high line charging capability. Besides being inexhaustible, it is pollution free and non-inflammatory in character. It helps in infrastructure development of the remote and hilly areas. In this age of ozone depletion and global warming, we have to look up to hydropower as the energy source of the future. World over, the recent concern has been on the increasing amount of CO2 in the Earth's atmosphere due to excessive burning of fossil fuels, and to curb this emission, we must switch over from fossil fuel based energy to the clean hydropower. There are several other technical advantages, vice versa, other conventional forms of energy. Renewable source. Hydropower is a renewable source of energy, whereas for generation of 1000 GWh of electricity by thermal station, 0.7 million ton of coal is required to be mined, transported and burned. It is non-polluting source of energy with high conversion efficiency and does not contribute to greenhouse effect, whereas generated billion units of thermal generation, 1 million ton of CO2 is released into atmosphere. Conversion efficiency of thermal plant is also about 40% as against 85% for hydro, which means that for every 1 million units actually generated, 1.5 million units are being waste. Multipurposes. Storage type hydro projects provided additional benefits of flood control, irrigation, drinking and industrial water, navigation and tourism. The low temperature water from the reservoir can be provided to thermal plant downstream for meeting its requirements. Cheap power. As compared with other sources, generation cost of hydropower is quite less. Actually, it becomes cheaper with passage of time. Longer life. As compared to life of 25 years of thermal plant, the envisaged life of hydro plant is 35 years. But in actual, the life of hydro plant is much more, and with minimum renovation, the life of hydro plant can be enhanced considerably. Reliable source. As the hydro plants can be started or synchronized and raised from no loads to full loads in minutes, they can pick up and drop loads as per requirement of system, and as their forced outages are rare and as they require minimum maintenance, the hydropower can be well described as reliable source of energy. The plant availability in case of hydro plant is generally of the order of 85%, and as compared to thermal, we can avail the same benefits and results if we set up hydro plants of capacity of 66%, the thermal capacity. Due to the above facts, hydro plants contribute substantially to overall system stability and reliability and results into optimal operation of system. Overall development. As hydro plants are located in difficult areas, their setting up improves the road rail linked communication. They provide employment and gear up the economy of that region. Disadvantages of hydropower. There are many disadvantages of hydroelectric power, due to which it is not used on very large scale all around the globe. Before employing something on the industrial level, you should consider its pros and cons. So, the disadvantages of hydropower are as follows. Emission of methane and carbon dioxide. The reservoir of water from hydroelectric power releases a large amount of carbon dioxide and methane. Disturbances of habitat. The formation of large and huge dams destroys the living being around them. Very high installation costs. Dams are extremely expensive to build and must be built to a very high standards. Limited use. As the hydroelectric power is produced by the water which depends on the yearly rainfall, so only those areas can use this method which reserves a good amount of rainfall water because this method needs a huge reservoir of water. Divert natural waterway. Dams and rivers collect water from the production of electricity which alters the natural system of water flows, thus depriving houses of water they need. Effects on agriculture. Making dams on rivers affect the amount, quality and temperature of water that flows in streams which has drastic effect on agriculture and drinking water. Fish killing. The water while flowing through the dam collects nitrogen which can damage also kills fish. Disputes between people. Changing the river pathway and shortage of water can cause serious disputes between people. Breaking of dams. Many dams which were built for industrial use or for mills are not now used and occupying a great place, but they can't be broken or removed as it would cause serious flooding. These would not only affect the humans but also building and properties. Deposition of silt. Dams prevent those seasonal flood and allow silt and vegetation to clog up river backwaters. This causes changes to the environment which may impact plant and animal habitats. Changes in reservoir and stream water quality. Building a larger dam alters the natural water table level. This is slowly leading to damage of many of accident monuments as salts and destructive minerals are deposited in the stone work from rising damp caused by the changing water table level. Hydrology dependent. Precipitation. An adequate supply of water from rain or snow is required from hydroelectricity plants to continue operation. If a drought occurs, electricity production can be severely affected. Geological damage. The flooding of large areas of land means that the natural environment is destroyed. The buildings of large dams can cause serious geological damage. Displacement of local populations. Usually a large area of land has been flooded to ensure a continuous flow of water to the turbine. In some cases, when the dam is built, large populations have to be relocated. The 2013 Uttarakhand tragedy. In June 2013, a multi-day cloudburst centered on the North Indian state of Uttarakhand caused floods and landslides in the country's worst natural disasters since the 2004 tsunami. Though some parts of Himachal Pradesh, Haryana, Delhi and Uttar Pradesh in India experienced the flood, some regions of western Nepal and some parts of western Tibet also experienced heavy rainfall. Over 95% of the casualties occurred in Uttarakhand as of 16 July 2013, according to figures provided by the Uttarakhand government. More than 5,700 people were presumed dead. This total includes 934 local residents. Destructing of bridges and roads left about 1 lakh pilgrims and tourists trapped in valleys leading to 3 of the 4 Hindu Char Dham pilgrimage sites. While heavy rain and cloudbursts were natural, the tragedy that followed was entirely man-made. Claims geologists. They said the heavy loss of life and property in that village was the result of criminal oversight over the decades of the state geological features and water channels by various authorities. These features are well mapped and documented, but engineers and builders choose to overlook them. The geologists identified 4 major ways in which constructions flooded significant norms. First, the seismic faultiness of this earthquake-prone state was not kept in mind while building roads. This tectonic faultiness, which are active and seen back and forth movements, has been cut in many places by roads. More dangerously, roads are built along the faultiness at many places. As a result, tiny seismic movements in the faultiness weakens the rocks at the base of the roads, making these stretches susceptible to cave-ins, the slides. The second area of rampant neglect was drainage. The road engineers had provisions for draining out all rainwater that can possibly enter the stretch. Where 1 to 2 meter bridges are required, they build small culverts at places where drains have been provided for. They were usually fitted with debris. Buildings have been constructed over old drains and streams, blocking the natural pathway of rainwater. One of the reasons for the devastation at Kedarnath was the people had constructed houses on the west stream of the Mandakini river that had been dry for decades. When the river returned to its old course flowing the delta, these constructions were washed away. Another type of transgression, similarly to the previous one, was construction taking place on river floodways. A floodway in areas covered by the river at the time of its biggest flooding in the past 100 years. Constructions have taken place on the lower terraces which were part of the floodway. Sooner or later, water would get to these places. Lastly, roads have been built over the debris of previous landslides, costlier to build paths higher up to the hills where the rock is firmer. Because authorities do not pay attention to basic scientific principles, the state pays with human lives and huge property losses. The Mullaperiyar Dam is a masonry gravity dam built over the river Periyar in 1895 during the British colonial rule, with a predicted lifespan of 50 years to divert water eastwards towards the Madras Presidency area, present-day Tamil Nadu. The diverted water from the dam is used for irrigation in Shivaganga, Theni, Madurai and Ramantapuram districts. The Periyar power station in Tamil Nadu produces hydroelectric power from these waters and distributes that electricity in Tamil Nadu. In 1979, there were few minor earthquakes experienced in the region surrounding the dam, following which safety concerns were raised over the dam. Since then, both states Kerala and Tamil Nadu have been at loggerheads with each other on the issues. A state agency had reported that the dam will not withstand an earthquake above magnitude 6 on the richer. Now getting into the controversial part, the catchment areas and river basin downstream includes 5 major districts of central Kerala: Idukki, Ernakulam, Kottayam, Alappuzhi and Thrissur, which has a total population of 3.5 million people scale. Experts had mentioned that the structure will not withstand an earthquake and is under serious threat. After all these reminders and 32 years of legal battle, both parties have not reached a consensus on this issue. Even after the Kerala government's promise to give water and a new dam, undertaking all the expenses, subsequent Tamil Nadu governments have turned a blind eye towards any suggestion or negotiation by Kerala. The reasons raised by Tamil Nadu are water scarcity in 5 districts of Tamil Nadu, which will lead to drought in the region. A valid reason in response to this, Kerala government has promised to deliver the same amount of water to Tamil Nadu without fail. Here arises the concern of people living in the downstream of the river. If the Mullaperiyar Dam collapses, 3 dams downstream, Idukki, Cheruthoni and Kollamavu, won't be able to withstand the incoming water around 15 TMC, which in turn will break these dams, resulting in a catastrophe that will put at risk the lives of 3.5 million people. A dam which has suppressed its lifespan by more than 66 years poses a threat to the lives of 3.5 million people living in 5 districts of Kerala. If any earthquake causes the dam of collapses, it can threaten the lives of 3.5 million people downstream. The issue needs to be looked at as a national problem, not as a dispute between 2 states. Summary: Indian power system has not been developed in a required manner and need hydropower potential development on fast track basis. The exorbitant fund requirement to meet the gigantic challenge cannot be met with the budgetary supports of centre or state governments. A cooperation between government and private sector is essentially required to develop projects in a time-bound manner. To facilitate smooth execution of the project, it is necessary that government policy should be such that the private sector finds easy approach in handling development of hydro sites, since for individual developers, tackling various agencies for seeking clearance or information would be difficult. Need has been recognized for accelerated hydropower development in India. 80% of the existing hydro potential is still unharassed. Hydropower projects are still in the state of evolution, with the process proving to be slow and expensive. Small projects will continue to be developed, but there is a danger that interest will falter in the larger projects if prospective developers continue to face with high upfront cost and long gestation periods with only limited prospects of success.